Hello, I'm Dr. Ron England, and what we're going to do today is create in JavaScript, a linked list from scratch. And if you look at the screen here, you'll notice that you should see a fairly familiar looking thing here, my beautiful JSFiddle that is blank. So we're going to start with a blank screen, and then when time we're done, in the next few minutes, you're going to have a fully functional linked list. So let's go and start on how that works. Well, first thing I'm going to do, and I'm going to go into JavaScript, I'm going to set it from unload to no wrap in head. Okay, that's just a function of the JSFiddle that allows you to create the code the way I want to create the code. So how do we do this? Well, let's first create the linked list. Function, spell it correctly, function, linked list. Okay, and that function, my linked list, the way I'm going to do it, should have a head, and I'm going to set the head originally equal to null. I'm going to make the function also have a tail, which I'm going to set to null. And now, the only thing it actually needs is a head. But I'm also going to give it a tail and a length. And the reason I add certain properties in when I do this is I want to be able to access those properties very quickly. Because the reality is if I create a linked list and it has a head and it's a functioning linked list, I can always find the tail by writing a function that finds the tail. Well, that's it. I have a linked list. Of course, it doesn't do a whole lot. There's nothing that's in my interface or anything, but it's there. Now, in JavaScript, everything is an object. So this is an object. It's called a linked list. It has a property called head. It has a property called tail. It has a property called length. Well, that's not everything that you need. So let's keep going. So the next thing I need to do as a linked list is you need nodes. So let's define what makes a node. So I'm going to call this function node. And now my nodes, I have to make a decision of, well, what do I want my nodes to have? Well, I'm going to make this a doubly linked list, which means that I need to have this dot next, which is a pointer to the next node in the list. And I'm also going to make another one called prev, or previous, but I'm going to call it prev. I'm going to make it equal to null. And you know what? The node isn't very useful if it can't contain anything, so I'm going to put in another property called content, and it's also null. Great. I now have a node. I now have a linked list. But it really doesn't do anything. So the first thing that we might want to do is let's create, in my linked list, the ability to add nodes. Now, the reality is, to make this truly useful, I don't necessarily need to add nodes. I need to be able to add content, which would then be held by the node that would be held by the linked list. So how do I do that? Well, I've already created this thing called a linked list, and I have in JavaScript this wonderful thing that allows me to extend the linked list and give it more properties and more functions or methods called prototype, P-R-O-T-O-T-Y-P-E. And the prototype that I'm going to create for this one is going to be a function called add. So I'm going to add to the linked list a function called add, and the way I do it is say linked list.prototype.add, and now I'm going to say what add actually is. Well, in JavaScript, everything is an object. A function is an object, so this object called that is add, which is going to be a function, okay, and I just now have to tell it what that function has to do. Now, the reality is it doesn't do much good if I don't actually pass some information for it to add. So notice I created this function. So I'm going to put in this content that's going to be passed to the add function. Now, notice I put an underscore in there. Why did I do that? There's no reason I have to have an underscore there. I just do that because when I see that underscore, I know it's something that was passed to the function, not something that is a property within the function. It just tells me it's my own personal convention for doing it. You can have your own conventions. That one is mine. Now, what do I need to do here? Well, the first thing I think I'm going to do is I need to create a node from that content, because I'm not going to add content. I'm going to add a node that contains the content. How do I know that? Well, a linked list doesn't have a property called content. A node has a property called content, and a linked list is just a bunch of nodes linked together. You should know that if you've looked at the lectures on linked lists. So here's what I'll do. let's create a node. There, node, it's case sensitive, so I'm going to make this a lowercase node, is equal to a node. All right, now I've created a node. The node doesn't have any content yet. So on the same line, just because I know that this is all really one step, I'm going to set the content property of this node equal to the content that I just passed over to the function. Great. Now I have a node. Node isn't part of the list. It's just a variable that is defined within that function. Now, what I have to do next is I have to decide, oh my gosh, it's a doubly linked list, and I got to figure out, well, where does this node go? So we got to make some decisions. So the first decision, which is the easiest, is I'm going to say if this dot head is equal to null, well, if the head is equal to null, it's an empty list. There's nothing in it. Well, that's pretty easy, because if that's the case, all I got to do is say this dot head is equal to the node that I just created. Ha ha ha, that's easy because it didn't have one, so now the head becomes the first node that it creates. And I'm going to make the length equal to 1 because it's a linked list with a single property, and then I'm done. If that's the case, and I'm going to return the node. Because in the add function, you're adding a node, I'm going to make it so that it returns the node. Now, I could just as easily have decided that I was going to return the list, which may make sense. In that case, I would just say return this. But what I really want is to return the node that was being added in the add function. Voila. Well, obviously, the only case of the linked list is not the case where there is nothing in it. So you actually have to look at the other situations that occur. Well, let's look at the next situation that might occur. What if it has a head but nothing else? Well, if it has a head, the this.head property is going to be equal to the node, okay, that you just created. In other words, it's not going to be null. But the tail will still be null. So that's the next case we can take into account. This.tail is equal to null. Now, what do we need to do? Well, it's pretty simple. We need to add that node and make it the tail. The head's still going to be the head, but you're going to tack that node onto the end. So you're going to go ahead and make the node that we just created. By the way, the node was not created within the if statement. It was created outside the if statement, so the node still exists. So all we got to do is tack that on. Well, this is pretty easy. This.tail is equal to node. Well, great. The tail's now the node that you just created. But there's a little bit more to this because it's a doubly linked list. If you know anything about your linked list, you know that, hey, the nodes got to point at each other. So what do we mean by that? Well, this dot tail dot previous, that's the pointer in the tail that should be pointing to the node before it. Well, that should be pointing to the head. Okay, well, that's pretty straightforward. What about the this dot head dot next? Well, the head pointer should be pointing to the tail. It's equal to this dot tail. Well, that's not that hard. And we also now know that the length property, it's going to be not a one node, it's not going to be a single node linked list. It's now got two nodes, so we can say this dot length is equal to 2. Or we could have just said this dot length plus plus, which would have done the same thing, and we can go ahead and return the node. So far, this should be making perfect sense to you. Now, if it wasn't the head that needed to be created, in other words, it was an empty linked list, and if it wasn't the tail that needed to be added on, in other words, it wasn't one with just one node, it means that it has to be a linked list with at least 2 nodes. It has to have at least a head and a tail. Okay, now remember, you don't actually need to have a tail property for this. I just decided that in my linked list, I wanted to keep track of the tail and the head both. Okay, you can write this code in a lot of different ways. If you didn't have a tail property, this code would be a little bit different, but you still can do the same exact functionality. Because remember, all the nodes point at the other nodes. So, what can we do now? Well, we now know that there was at least a head, at least a tail, so somewhere this node is going to be tacked on to the end of the tail. So the tail is going to change. So how does this happen? Let me move this up so you can see it. Or I can move this down so you can, up this way so you can see it a little bit better. Whoops, I went a little bit too far there. Hopefully you can actually see the code that I'm writing. I'm trying to figure out how to make this fit a little bit nicer, make it a little bit more friendly to you. I know what I can do. I'll go here, and I'm going to go up, 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 and that's going to move it up a little bit. There we go. Now, so what are we going to do? We're going to tack on this node to the tail. How do we do this? Well, we know that the current tail, this dot tail, is going to be equal to, is going to have its next pointer, notice the pointer after that, equal to the node that I just created. So now the tail pointer of the current tail just got set to be the new node, which now puts it at the end of that tail. And the node previous is going to be pointing to the current tail. Okay, well that part's straightforward. I just put the pointers pointing to each other, but the tail is still pointing to the next to the last node. Well, that's easy to fix too. This dot tail is going to be equal to the node, okay? And voila, I can return the node, and all the nodes should be pointing at all the right places, and I've just created a successful add function. I hope, I haven't tested it, I'm kind of hoping this is going to work, but in my logic in my head, this should work just fine. Now, before I can really test this, I kind of need to have a function that will print it out because I want to test it and see what happens. So let's do that. Let's create a print function. And this is actually kind of a nice exercise. Linked list dot, okay, and it's going to be a prototype function. I'm going to call it print. And it's going to be a function. And what that function is going to do is it's going to return a string of the list that I can actually put onto the screen. Well, we do know one thing. If this dot head, and remember that this keyword works because it thinks it's still part of the linked list because this is a prototype of the linked list. So this is the definition of a linked list. That's what the this refers to. Now, if this dot head is equal to null, okay, well, then if that's the case, then this is an empty list. So what we can do here is we're just going to return the string empty list. Okay, so that one's pretty straightforward. But what we're going to need to do now is if it's not empty, let's go ahead and make an empty string here, and let's just parse through each of the nodes and add the content of each of those nodes to that string. Well, how do I do that? Well, that's pretty easy. I'm going to say var node is equal to this dot head. Okay, well that's not too bad. So I'm going to make a node that is the head, and then I'm going to do while this node is not null, node is not equal to null. Let's just parse through each of those, and now you can't see anymore, so I'm going to have to come down here and add a whole bunch more spaces so you can see while the node is not equal to null. Okay, let's do this. Let's take this s variable, which was my string, and let's add the content of the node. And I want to make this look pretty, so I don't want to just put the content there because it's all going to string together. Let's put a few spaces in there, and then now all I got to do is after it's done at one time, I'm going to set the node equal to the next node. So it's just going to go on to the next node, and remember they all point at each other, so this shouldn't be a problem. And when all that is done, I'm going to go ahead and return that s. All right, now, kind of hoping I haven't made any mistakes here, but if I haven't made any mistakes here, I should have something that works. Well, here's the thing, is I don't have any way to test this, so let's create a way to test this. Now, how am I going to do this? Well, I got an easy way to do this. I'm going to go ahead and create a text box and a button, and every time I hit the button, it's going to add the contents of the text box to make a new node and add it to the list. Well, that's not hard to do either. I'm going to use my good old going up here to HTML, so I'm jumping up. I'm going to make first the text box. That should be easy. Whoops, I'm going to put that in quotes, text box. And I'm going to make I have to have an ID because I need to reference it. So I'm going to make the ID V. It's really creative. And I'm going to make the value a default value of node 1. And that should be sufficient for the input for the text box. And now I need a button. So input type equals, this time it's a button. And now on the button, I need to put a value that actually makes sense to me. So the button is what's going to happen, is going to say add node on the button, and I need it to actually do something. So on the onClick event, I'm going to have it call add node. Now here's the problem is I have not created add node. I've got a defined linked list. I've got a defined node. I've even got a print and an add function, but I don't have an add node for this thing to call. And I also don't have an out place for the output. So let's create a little div here, and I'm going to call this ID equals output. I need a place to put the results, and there it is. Okay, so I've now created a little blank spot for it to do this, and if I hit run, I should actually see over here node 1, add node, but if I click it, it's not going to do anything at all. Well, it's actually doing something. It's calling a function that doesn't exist. So what do we need to do? Well, simply put, we need to create that function. So let's say function add node. Okay, that should match add node. It all looks like it matches quite well. And let's do this. Well, first thing I want to do is I want to go ahead and get the variable. I want to get what's in the contents of the text box. So I'll call that C is equal to document dot get element. I'm not using jQuery here. I'm doing this the hard way. ID. And the ID of that was V. I did at least make a nice easy ID dot value. So now whatever's in that text box is now in variable C. I don't have a linked list. I have a definition of a linked list. I don't have a linked list. I have never instantiated the linked list. I got to do that before I can use it. Now, for simplicity's sake, I'm going to make that global. I'm going to make a new list, and it's going to be global. Okay, well, how do I make a global list? I simply instantiate one outside of the function. How do I do that? Well, there, a list, okay, there I got a list, is equal to new, and the whole thing was a linked list, so I say linked list, and now I've got a linked list called a list. This is not an instantiated object. You can't do anything with that. This is an instantiation of an object of this type. I can do something with a list, and since it's global, I can do that something inside of this function because it's visible everywhere, my variable a list. So what am I going to do? A list, well, a list has a function called add that I created, a prototype function, and I'm going to add that C, which was what was in the box, to it. And what can I do now? Well, I need to output it. So how do I output it? Well, I know I've made a div called output document dot get element by ID, and what I'm going to do is for that ID, it was output. Remember that div was output. And let's see. Now, I'm going to put this, the actual string in the HTML of that div. So inner HTML is the property that I want to go ahead and fill in. And what I need to do is, well, I have the list, but really that's not going to look pretty if I make that HTML equal to a list. What it's going to say is that, oh, yeah, this is an object. But remember, I created a property, I created a function called print that was there, and alist.print should return a nice pretty string that's going to go over there. So now if I run this whole thing here, and now I've got node 1, if I click this, I should see, oh, it doesn't work. Okay, well, what does that mean? It doesn't work. Did I do something wrong? Okay, well, now we're going to have to get into saying, well, I might have done something wrong. What did I do wrong? Well, one of the things that you can do here is you can obviously go over to your developer tools, and you can look at these and say, okay, nothing happened. What's the problem? And one of the things you're going to need to do is you are going to need to know how to do debugging. And what I typically do in my debugging is I'm going to run multiple windows of this stuff all at one time when I'm debugging. But first thing I'm going to do before I actually go into that debugging is I'm going to just simply go through the code that I have and say, is there anything obvious that I might have made a mistake with? Okay, up here is my input. Does it look nicely formatted? On my on-click, does it look nicely? I mean, does this all look good? Does it look like I expect it to look? Because that's the first thing that you're usually going to have when you have a mistake. Is something like that, and you want to be able to spot it right off the bat. So I'm going to go through this. I'm going to say, okay, what could I possibly have done wrong? Well, right off the bat, I found something that I did wrong, but it's not something that should cause this not to work. Notice I set the length here with the head. Notice I set the length here with the tail, but I didn't set the length here when I was adding other nodes. Well, that could become a problem later on, so I need to fix that. So I'm going to say this dot length is plus plus. I'll just go plus plus because that'll do is increment the length. Okay, so now I know that I made one mistake there that I just caught. What else could I possibly have here? Let's come down here and look at the print. Okay, And this is worthwhile. I'm saying you should not just jump out and say, oh, I know I obviously could not possibly have made any mistakes. Let's see what, let's actually spend some time and look at this and see it. All right, so I'm going to make this move up a little bit because you can't see that add node function very well. Okay, now you should be able to see this. Okay, well, where could this possibly be? Okay, well, let's try it run again. I've got node 1 right here. I hit add node. Nothing happened. Okay, let's figure it out. All right, so hopefully you found my error. And I actually went past it over and over again. And it's even color-coded so you can find it. See it? Return. Yep, that's enough to break it. Let's run. Let's add a node. There it is. Let's change the value to 2. There it is. Let's change the value to 3. There it is. I now have a linked list with 3 nodes. One bug caught, whole thing up and running, ability to add nodes through an interface to the linked list. I don't have the ability to remove it. And well, before I leave, let me talk about a little bit more, just a simple thing here. But once you've got this linked list, how do I turn it? There's some very useful, linked lists are very useful because they're dynamically ability to store stuff. But what else can you do with it? Well, the linked list can easily become a stack. How does it become a stack? I simply now add. To make it a stack, I need to add 2 properties. Linked list prototype dot push. Okay, define that one. And define the other one, pop, which means you actually have to write the code to do it. But as you can see, that's pretty much it. You add those 2, the linked list is now a stack. And how do I make it a queue? Okay, add NQ and DQ. And you don't even have to write NQ because NQ is the exact same thing as add. So that's pretty easy too. So this linked list can easily be converted into both a stack and a queue by the simple addition of 4, but 1 that's already written, functions that would be prototype methods of the linked list itself. Wow. Really, it is that straightforward to do a lot of this stuff. And hopefully this was tremendously useful to you in your development of linked lists and the understanding of how to write this code and put this together. Thank you very much. Ron Eaglin, Dr. Ron Eaglin signing out. Good coding.